Elementary statistics, practice test number 1 or module 1, which deals with chapters 1, 2, and 3. Chapter 1, Introduction to Statistics. Chapter 2, Exploring Data with Tables and Graphs. Chapter 3, Describing, Exploring, and Comparing Data. The value of variance and standard deviation is never negative. Is it true or false? This is a true statement, because when we look at the concept of variance and standard deviation, these are absolute quantities that is a measure of variation of all values from the mean. It can also be zero. All you have to do, look at the formula, whether we look at the sample variance, sample standard deviation, population variance, or population standard deviation. The numerator is sum of numbers that are being raised to the power of 2. The denominator is a whole number, so that makes it positive or maybe zero. When you take a root of that, is also positive or zero. What kind of variable weights of bear is? It's quantitative. It gives numbers that represent counts or measurements. Gender would be qualitative. It's distinguished by non-numeric characteristics. There are numbers that are considered qualitative simply because they don't have a numerical value, such as the zip code or student ID. Define population and sample. Population is the complete collection of all elements, scores, people's measurements, etc., to be studied. A sub-collection, portion or fraction of elements drawn from a population, is a sample. In short, population refers to the whole, sample refers to a portion. The value of the middle term in a ranked data is called the median. How do you find the mode? Mode is the value that appears with the greatest frequency among the data. A data set can have one, more than one, or no mode when all numbers appear with equal frequency. The number of chairs is considered to be continuous. That is a false statement. The number of chairs is not continuous. We cannot have 1/4 of a chair. So let's define a discrete and a continuous variable. Data result when the number of possible values is either a finite number or a countable number of possible values, such as 0, 1, 2, 3. Example, number of students in a class, number of cars in a parking lot. In the case of the continuous, data that can take any value in an interval, data result from infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, interruption, or jumps. It's an interval, such as the weight or height of a person. What is a Pareto chart? What does each axis represent? A Pareto chart is a bar graph for categorical or qualitative data, similar to histogram for quantitative data. The vertical scale represents frequencies or relative frequencies, and horizontal scales represent different categories. Bars are arranged in descending order to emphasize the order of impact. Define a parameter and a statistic. Parameter is a numerical measurement describing some characteristic of a population, whereas statistic is a numerical measurement describing some characteristic of a sample. Normally, in the case of a parameter, we use Greek letters such as mu and sigma. Mu represents the population mean. Sigma represents the population standard deviation. In the case of a statistic, we use Latin such as X bar and S. Define a random sample and simple random sample. Random sample. Members of the population are selected in such a way that each individual member has an equal chance of being selected. simple random sample, or SRS, we call it. Subjects selected in such a way that every possible sample of the same size n has the same chance of being chosen. In other words, in the case of a random sample, every subject has the same chance. If you have 30 students in class, every student has to have the same chance of getting picked of 1 out of 30. But a simple random sample, you have to come up with the sample size first. For example, sample size of 5, then every sample size of 5 must have an equal chance of getting picked. You find the following types of sampling: systematic, convenience, stratified, and cluster. Systematic sampling: select some starting point and then select every kth element in the population. As an example, in a population of 50,000 people, a statistician selects every 100th person for sampling. Convenience sampling: use results that are easy to get. For example, standing at a mall or grocery store and asking people to answer questions would be an example of a convenience sample. Stratified sampling: divide the population into homogeneous groups. Homogeneous meaning the subjects within the same subgroup must be similar and share the same characteristics. Subgroups called strata, and then obtaining a simple random sample from each subgroup strata. Cluster sampling: divide the population into sections or clusters, non-homogeneous subgroups, then randomly select some of those clusters and choose all the members from those selected clusters. So this is a good way to describe this. In the case of a stratified, the groups that you choose, each group is homogeneous, they are the same. For example, let's say you're interested in picking a few students from a class randomly such that some are A's, some are B's, some are C's. If this represents A's and B's and C's and D's, you pick a few from each group randomly. So this is stratified sampling. However, if you look at cluster sampling, each of these represents the class. For example, this one has some A's, B's, C's, and D's in it. Same thing for the rest of them. You can pick one group randomly and keep every member, or if you need, you can pick more. What are different levels of measurement of data? Give examples. Nominal. Level of measurement is described by data that consists of names, labels, or categories only, and the data cannot be arranged in some order, such as low or high. In short, it's qualitative. Survey responses: yes, no, undecided, eye colors, blue, brown, black, others, political party, so on and so forth. Ordinal. Level of measurement involves data that can be arranged in some order, but differences obtained by subtraction between data values either cannot be determined or are meaningless. Ranks of colleges: that would be an example. Rank can be first, second, third, and so on, which determines an ordering, assigning grades A, B, C, D, and so on. Interval level of measurement involves data that can be arranged in order, and the differences between data values can be found and are meaningful. However, there is no natural zero starting point at which none of the quantity is present. A value of 0 doesn't mean the absence of the quantity. Arithmetic operations such as addition and subtraction can be performed on values of the variable. As an example, body temperature, 98.2 degrees Fahrenheit, 98.6 degrees Fahrenheit, years, 1,000, 2,000, so on and so forth. Ratio level of measurement: data can be arranged in order. Differences can be found and are meaningful, and there is a natural zero starting point where 0 indicates that none of the quantity is present. Differences and ratios are both meaningful. Arithmetic operation such as multiplication and division can be performed on the values of the variable. Examples: distance traveled. 0 kilometer represents no distance traveled. And 400 kilometers is twice as far as 200 kilometers. Prices of books. $0 does represent no cost, and a $100 book does cost twice as much as a $50. What's the difference between an observational study and an experiment? Observational study: observing and measuring specific characteristics without attempting to modify or influence the individuals being studied. In an observational study, the researcher merely observes and tries to draw a conclusion based on the observations. As an example, a study took a random sample of adults, asking them about their bedtime habits. The data showed that people who drank a glass of warm milk before bedtime were more likely to go to sleep earlier than those who didn't. Experiment: apply some treatment, and that's the key, some treatment, and then observe its effect on the individuals. The individuals in the experiment are called experimental units, and they are often called subjects when we deal with people. In other words, an experiment is a controlled study that aims to determine the effect of one or more independent variable or factor on dependent variable. Any combination of the values of the factors is called treatment. The researcher manipulates the independent variable and tries to determine how the manipulation influences the dependent variable in an experimental study. So the key is the treatment here. Here's an example. Another study took a group of adults and randomly divided them into two groups. One group was told to drink warm milk every night for a week, while the other group was told not to drink warm milk that week. Researchers then compared when each group fell asleep. Describe cross-sectional, retrospective, and prospective studies. Give examples. Cross-sectional study: data are observed, measured, and collected at one point in time. A cross-sectional study is like a snapshot of a particular group of people at a given point in time. It is used to describe what is happening at that time. As an example, a medical study examining the frequency of cancer among population of different geographical locations. By doing this, any differences among them can most likely be attributed to geographical locations differences rather than something that happened over time. Retrospective study: data are collected from the past by going back in time, data that already exist. Example: researcher ask participants about their smoking habits over the past 20 years. Then they can analyze any possible correction between their smoking habits and diseases such as lung cancer. Prospective study: data are collected in the future from group called cohorts, sharing common factors. Here's an example. A medical study follows a cohort of middle-aged people who vary in terms of smoking habits to test the hypothesis that the 20-year incidence rate of lung cancer will be higher among heavy smokers, followed by moderate smokers, and then non-smokers. What is sampling error, non-sampling error, and non-random sampling? Sampling error is the difference between sample result and the true population result that is the consequence of chance sample variation. Non-sampling error The non-sampling error occurs due to data that are incorrectly collected, recorded, or analyzed. It may happen by selecting a biased sample, using a defective instrument, or copying the data incorrectly. Non-random sampling error is the result of using a sampling method that is not random, such as using a convenience sample or a voluntary response sample. As it appears, sampling error is simply the result of the difference in numbers, the sample size, and the true population in essence. Voluntary response sample or self-selected sample, one in which the respondents themselves decide whether to be included. In this case, valid conclusions can be made only about the specific group of people who agree to participate. What are some characteristics of an experiment? Confounding. It occurs in an experiment when the experimenter is not able to distinguish between the effects of different factors. Blinding. Subject does not know he or she is receiving a treatment or placebo. Placebo is like a sugar pill. Blocks. Groups of subjects with similar characteristics are called blocks. Completely randomized experimental design. Subjects are put into blocks through a process of random selection. Replication. Repetition of an experiment when there are enough subjects to recognize the differences in different treatments. Sample size. Sample size must be large enough to display the true nature, and that's the key, the true nature of the population data, and should be obtained using an appropriate random method. Explain some misuses of statistics. Bad samples, small samples, misleading graphs, distorted percentages, loaded questions, order of questions, refusal, correlation and causality, self-interest study, precise numbers, partial pictures. These are some of the misuses. So as an example, pictograph, double the length, width, and height of a cube, and the volume increases by a factor of 8. To correctly interpret a graph, we should analyze the numerical information given in the graph instead of being misled by its general shape. So in this case, as far as cube is concerned, the volume is S cubed. So if we use 2S, we double the size. Now this is 8S cubed. That's why it gets 8 times. So we want to be careful as a result of that. An example of deliberate distortion with loaded question. We received 95% yes and 53% yes here. What's the difference? Look at the first question. Should the governor have the line item veto to eliminate waste? Versus should the governor have the line item veto or not? That makes a huge difference. So this is a loaded question example. If sample data are not collected in an appropriate way, the data may be completely useless. That no amount of statistical training can salvage them. Randomness typically plays a critical role in determining which data to collect.